So far we've talked about solving systems of equations that we've always gotten one solution, right? So for all of the methods we've done so far, we've always gotten one solution. It is the point where the lines intersect, right? And we name that ordered pair, and that is our solution to the system. However, there are other situations with systems of linear equations that may arise. Okay. What? No, not for linear equations, but for other types, yes. Okay. We can have one solution. So this is what we've seen thus far. One solution, this is where we have that ordered pair of x and y where the lines intersect. Okay? So that's like what we've seen so far. On graph, we would see the intersection. Okay? The lines intersect. That's what we've seen. That's what we know so far. But there are also two other possible situations that we could have. Okay, we could also have no solution. Now this is going to happen when the lines don't intersect. What kind of lines don't intersect, Joey? Parallel lines. So if we end up with a system and the lines are parallel, they will never intersect, so there will never be an ordered pair that we could say is a solution. So if you end up with parallel lines, whether you see it on graph, or what's the other way that we identify parallel lines, Charlie? Yeah, same slope, okay? Or if you can see, right, if it's written in slope-intercept form and you can see they have the same slope, you don't even have to graph. You can see that they're parallel, and you can say that the system will have no solution, okay? You must say that it has no solution. It's not zero. It's not 0, 0. It is no solution, okay? So what it would look like on graph is two parallel lines, which we know by definition never intersect. So what we're looking for, parallel lines and the same slope. Okay, because they'll never intersect. The last possible situation that we can have is that there could be infinitely many solutions. And we can abbreviate this if you want to just say IMS. That stands for infinitely many solutions. Bless you. And this occurs when what looks like a system is actually two of the same line. So like it won't be in simplest form, or if you rearrange it, you get into slope-intercept form, it forms the exact same line. So they'll both be like y equals 2x plus 4. And what that is on graph, they'll be literally, on top of one another, so the same line. Which means every point on one line is also a solution to the other line, which is why they have infinitely many solutions. Same line, meaning same slope and same intercept. So they will be literally the exact same line. Okay? Let's do a couple of examples. All right, example 1. To solve the system, y equals 2x plus 1. Y equals 2x minus 5. Okay, this is in slope-intercept form. What do you notice? Lainey? Good. They have the same slope. Meaning what is true about the lines? Joey? They're parallel. So what's my answer to this? Joseph? What's my solution? No solution. Yep. So it's asking us for the solution. We have to say no solution. We don't say that they're parallel, but the reason there's no solution is because they're parallel. Exactly. Good. No solution. Your answer, you put down no solution. Okay?
So like if they have those descriptions, they'll be like one solution.
Yes, exactly. Yep. Yep. All right, good. So like that's pretty easy when they give that to you and when you can see it in slope-intercept. If it's not in slope-intercept, get it in slope-intercept so you can see the slopes. Okay? Example 2. This one says solve negative 2x plus y equals 3. Negative 4x plus 2y equals 6. Okay, a couple different ways we can solve this, as always. We could graph it. We can get it into slope-intercept form and observe the slopes. We could use elimination. Oh no, I thought these were both opposites. So that might not be as easy. What should we do? What do you guys want to do? Charlie, what do you want to do? Let's put it in slope-intercept and compare slopes. Okay, this one's going to be pretty easy to get into slope-intercept. We'll just add 2x to both sides. So we get y equals 2x plus 3. The nice thing about getting it into slope-intercept is then if it turns out not to be the same slope or the same line, it's ready for you to plug into your calculator to graph, right? Our second one, we'll add 4x to both sides. So we get that 2y equals 4x plus 6. And then we'll divide by 2 and divide every term by 2 when we do that. So we get that y equals 2x plus 3. What do we notice? They're the same line. So how do we write our solution when they're the same line? Riley? Infinitely many solutions. Or just IMS. Infinitely many solutions. Okay? Let's do a couple to practice.
Is this all?
Yep. This is all. This is all. You just have to know that these are an option, but they don't want to throw this at you during substitution and elimination. Like
a ribbon.
it is. Yeah. Just with the tiny bit of extra that's easy to understand.
So this is just solving it? That's what you have to
Yep.
do?
Yep. Just understanding that you're not always going to get an ordered pair. Sometimes you'll get no solutions. Sometimes you'll get infinitely many solutions. Yes.
Will they ask us to get it into substitution and then find?
Usually they say solve using any method.
So we can use this one. Well, I mean, would they say, how would we know how to solve this one? Or get the answer no solution?
Well, you would know that because you'd have to figure that out by getting it into slope-intercept form or by graphing and seeing that it's parallel. Okay, so they aren't going to tell you, solve and get no solution because then they give you the answer. So they'll say solve, and you'll have to look at the equation and either solve with one of the methods we've used or see that the slopes are parallel right away or get them into slope-intercept. So you'll have to sort of, as you work through, you'll figure out that there's no solution. I want to show you how to solve these using substitution and elimination and seeing what it looks like when there's no solution or infinitely many solutions. Lainey?
So like on the test, like when you say solve using substitution,
Yeah. Yep.
You could get like no solution.
Yep.
On that section.
Yes. Yep. Yep. So you can now that this door is open, it's open. You can always get either an ordered pair, no solution, or infinitely many solutions. So I want to show you how these look when you solve by substitution or elimination and it doesn't end up being an ordered pair. So let's look at what that looks like. Let's see. These are not like technically examples in the book, so we'll just call them our star. Okay, look at this. X plus y equals 3, and 2x plus 2y equals 6. You kind of start to recognize when certain types of equations are going to end up a certain way. But anyways, looking at this, when I look at it, I would say this looks like something I could use substitution on, because I could get one of these by itself very easily, right? So let's use substitution. All right, let's subtract y from both sides. And I get that x equals 3 minus y. This is extremely bright. Okay. Okay, now that I have one of my variables by itself, I will plug in this value for x. So I'll get 2 times the quantity, 3 minus y, equals 6. Did I do something right? Wrong? Plus 2y, yes. Plus 2y equals 6. Good. Distribute 6 minus 2y plus 2y equals 6. So then notice what happens here. We lose the variable. This is a hint that it's not going to be an ordered pair. When we get a true, yep. Remember how when we would do these and we'd get like all real numbers, or if it wasn't true, it was no solution. It's the same thing now. Instead of saying all real numbers, though, because we're talking about systems of equations, we say infinitely many solutions. When you end up with a statement that is true, 6 equals 6, is that true? Yeah. Yes. When you end up with a statement that is true after you solve using substitution or elimination, a number equals itself, we say that there are infinitely many solutions. Okay? Correct. So if you end up with a statement that is not true, there is no solution. So let's just make ourselves a little note. When you end up with a true statement, the solution is IMS. So our options are, we would end up with y equals something or x equals something. In that case, we know that we're going to have one solution. We're going to have to get the other part of that ordered pair. Or we'll end up with a true statement, meaning infinitely many solutions, or we'll end up with a false statement, which will be no solution. So let's do one of those. Yes? Correct. If you got x equals x, then that would be infinitely many solutions because that's a true statement. No solution. Right. Exactly. So we kind of are thinking like, does this make sense? Like, is this true or is this not true? So we're going back to what we would do with equations and inequalities is more when we did this. Okay, let's do 2 stars. All right, this one, our system is y equals negative x plus 3. And 2x plus 2y equals 4. What method should I use here based on what I can observe? What method? Nathan? Let's use substitution, right? Because we have y by itself. Hold on. This is... So I'm going to use substitution because I already have y by itself, so it's going to save me some time. 2x plus 2 times negative x plus 3 equals 4. Then I'll distribute and simplify. 2x minus 2x plus 6 equals 4. 2x minus 2x cancels. I get 0. And then I get that 6 equals 4. Is that true? No, we don't get a true statement, meaning what is the solution to our system? Emma? No solution. Okay, so when you end up with a statement that is not true, such as 6 equals 4, that's not true, there is no solution. Okay, the last thing to remember, because then we start to forget that we can also just have one solution, is that you can also solve and end up with an ordered pair. That's not off the table. So let's just do one more to refresh our memories. This will be star number 3. X plus y equals 3. X plus 2y equals 4. Go ahead and solve. Go ahead and solve for, check your signs. Check your signs. If you did not get this, check your signs. That is often where mistakes are made, is with our signs, with our distribution, with our addition, subtraction, doing that wrong. Just silly mistakes. Yes?
So I did substitution.
Uh-huh.
But I got an X right.
Okay. So then you look back when you plugged in and see if you...
Oh, I know, but do I have to do a second time once I find X?
Yeah. Because are you done when you find X? No, you always have to find the ordered pair, the Y. So plug it in. So that's what I'm saying. Like sometimes we forget that if we end up with a true statement, it's infinitely many. If we end up with a false statement, it's no. But if we end up with X equals something, we've got to find the other part of that ordered pair. So we got to keep going, just like we've been doing. Okay?
Homework time?
Homework time.